Okay, girls, I want to just do task 7 with you again. Well, not again, but I want to do task 7 with you. There seems to have been a few misconceptions. So I want to just clarify a few things. So we have, what was this, octane plus 25 oxygens. So it was a combustion reaction with oxygen, giving you water and carbon dioxide. Oops. Okay, so I want to make it very clear of how to do this. These numbers here that are in front, they actually are called the coefficient, like in maths. So these numbers here are only for ratios. You only ever use them in ratios. You never use them in molar mass. Okay, so be very careful here. So what we were given is we were given 500 grams of that, of octane. And we wanted to know, well, how many grams of carbon dioxide would be produced. Now I want you to set it out like this. If you're not getting this right, set it out the way I'm setting. You're never going to get it wrong then. So what I do is underneath the octane, I'm going to work out what I need to. Now remember, the molar mass for octane is there are 8 carbons. Ignore the 2 in the front that is only used for ratios. This is octane, okay? Just that. This just tells us there are 2 octanes. But this is the formula for octane, and the formula for octane is the same all the time, which means the molar mass for octane, no matter how many there are, it will always be the same. So we have 8 times 12 plus 18 times the 1. So that 12 is the molar mass on the periodic table. That 1 is the molar mass on the periodic table for hydrogen. So when you do this, you're going to get a 114 grams per mole. Okay, that is your molar mass for octane, always and forever. So whenever you have octane, you already know the molar mass. Okay, and so now we need to work out the moles. So we work out the moles. All right. So it is our number of our mass, which was 500 grams, over our molar mass, which works out to 4,39. Now we are trying to get to carbon dioxide. So it's easy to go, okay, well, I want to go in this direction to carbon dioxide now. And the ratio is a 2 to 16. It's okay if you put 1 to 8. It's really fine, but it's okay to use 2 to 16 as well. Okay, so 2 to 16. The first one you get to, you divide. The second one you times. Be careful, because if the arrow goes in the opposite direction, then the first one you get to would be divide, and the second one you get to would be times. So if you do it in this way all the time, you will always remember how to do it if you follow the arrow. So we're following the arrow. The first one I get to is 2, so I divide by 2, and we times by 16. Okay, so we land up with 35,12. Now, because it's under carbon dioxide, I know that it's carbon dioxide. And we can say carbon dioxide, moles of carbon dioxide. Okay, now this is where we've used the ratios. Let me just make it so loud. That is the only time we use those big numbers, is when we are comparing the moles. Okay, so be very, very careful. Okay, we then need to get the molar mass. I'm just going to work out molar mass for carbon dioxide over here. So it's going to be carbon is 12 plus 2 times 16, which is oxygen. So that gives us 44 grams per mole. Okay, so if I work with this, mass over molar mass, we want the mass, and we times the 2, so mass is equal to number of moles times molar mass, so it's 35,12, which we got from our ratios, times 44, and you should land up with 1,545,28 grams. Now girls, please remember, if you are off by a few, like it can have an effect because the way you've rounded off your previous answers. So don't worry about if you are off slightly over here. Okay, as long as your chemistry is correct, it will be fine. So that's what I'm just going to do number 1 with you. Please try number 2 if you had a problem with this. So what I want you to get from this now is that whenever you're working out molar masses, you ignore the big numbers in the front. Okay, they are not part of a molar mass. The molar mass is the same no matter what reaction you're doing. So that's why we only use O2, we use C8H18, we use H2O, we use CO2. Another thing is that remember when you're doing your ratios, you divide by the one that you have. We have the number of moles of octane, and you times by the one that you need. You need carbon dioxide. Okay, so you divide by what you have, you times by what you need, the ratio, the moles that you need. Okay, I hope that helps.